Tonight's session is on data and ethics. We have two great speakers who are very knowledgeable in this area, and they will present to us their work. It's a topic that is often overlooked and is not getting a lot of attention, but the need for it is very clear, especially with recent events like Facebook being under investigation. We'll start with the presentation and have a panel discussion where we get to ask the speakers questions. Enjoy!
Good evening, everyone. Welcome to this new BCN Analytics session. Today is our session number 11, and I have to confess that this is the one I feel most excited about, because we are going to talk about two topics I feel really are relevant from my perspective at least: data and ethics. So for those of you active in social networks, the hashtag we are going to use is BCN Data Ethics. So if you ask me to summarize the 10 previous sessions of BCN Analytics in a word, probably usually like happiness, right? Because those of you attending the session have been seeing that we've seen that business and organizations are becoming more data-driven, which is good. We are seeing that sophistication of algorithms is not only machine learning, but deep learning is becoming more and more prominent. And also we've seen cool startups coming here and presenting how they are creating really cool companies by the using of data. So happiness, right? Not really. So how many of you have heard about this company called Palantir? I'm not talking about Palantir, Lord of Rings, but Palantir, the company. Raise your hands. Not many. Okay, Palantir is an interesting company, let me put it this way. They do a lot of predictive analysis, and some of the services they offer, they work for city councils. And if you read this article here, it's saying, well, they were offering these services to the New Orleans city councils, which is basically telling the likelihood of someone to commit a crime. So a couple of comments there. The first one is that some city members of council, they didn't know about Palantir offering this service, which is a kind of weird. But some questions that might trigger your mind. What if what Palantir is doing is inaccurate, discriminatory, and even more important, using unconstitutional data, which seems to be the case. That's a bit scary if you think about it. Then, Palantir, not many people, but how many of you have heard about the Cambridge Analytics, Facebook, let's say, more people? Those of you who haven't probably have been living in a cocoon, because yesterday we had Mark Zuckerberg in front of the Congress member of the United States talking about this. So data leaks, privacy, a weird use of certain private data. So go for it if you haven't read it, because it's really, really scary. But it's not only about Facebook. Let's talk now about another big brother, YouTube. YouTube is really a cool product, and I was researching a little bit a few weeks ago, and what they do is they use 2 layers of deep learning to make the recommendation. So from an algorithm perspective, it sounds like really cool. Well, you talk to this guy, Guillaume Chaslot. He was working at Google as engineering, and I'm literally quoting him, the algorithm does not appear to be optimizing for what is truthful or balanced or healthy for democracy. That's coming from someone who worked at YouTube. It's not a journalist, it's not an outsider, it's someone who worked there. So even more scary. Let me now quote Cathy O'Neill. She's a practitioner, a former practitioner, and nowadays is one of the most relevant persons when talking about this data and ethics. She is the author of a book I'm eager to read, which is named Weapons of Mass Destruction. So this is a long sentence, so I broke this sentence in 4 elements just for all of us to be aware of what Cathy is saying, because I believe she's summarizing very well the issues we are facing. So it's saying, the math power applications powering the data economy were based on choice made by human beings, which by definition are fallible, right? Some of these choices were no doubt made with the best intentions. That's really important. In the previous slide, we were kind of thinking about bad people, bad intention. That sounded a bit Donald Trump, the bad thing. But, but here we are talking about people who might have good intention. So it's not only about having a bad or good intention, because even with the best intention could happen what Cathy is suggesting. You will see in a few seconds. So nevertheless, many of the models encoded human prejudice, misunderstanding, and bias into the software systems, which, by the way, manage our lives. And, according to Cathy, these algorithms tend to punish the poor and the oppressed in our society while making the rich richer. So it's not only about privacy, it's only about how algorithms, how data can shape our lives and the justice in our society. So And this is, again, someone, a former practitioner, mathematician, so with really technical knowledge. And also to give another flavor, this is Mustafa Suleiman, who is the founder of DeepMind. I guess you all know DeepMind. Was bought by Google, and they have very sophisticated artificial intelligence. And the guy is recognizing, hey, we need to think about the moral and the ethics in artificial intelligence. It's about time. In the past, we haven't really thought about that, but now it's about the time. So today, we are going to talk about that. But before getting into the content of the data and ethics, let me do a bit of housekeeping on BCN analytics. First thing, I'd like to announce that a few weeks ago, we had 2 new members joining the core team of BCN Analytics. One of them is Alejandra Manrique. She has been working in Suez for many years on data projects. And also we have Didac Fortune, who is working as a data scientist of Allocate. So let me ask for a spontaneous applause to all of them. Thank you, very spontaneous. So let's keep talking about some housekeeping on BCN Analytics. You may remember in the previous session, we were talking about, hey, we're doing a datathon about pollution levels in Barcelona. We announced that. And that datathon happened. Different organizations work together to make this happen. So we have CCCB, Big Data Center of Excellence, Barcelona Supercomputing Center, Allocate, and BCN Analytics. And we were thinking about doing this datathon for a while, and at one point we said, we need some support, we need some sponsors, and we were lucky to find great sponsors, all of them based in Barcelona, so Allocate, a company investing on green energy, Social Point, company very successful in the gaming industry on mobile, also based in Barcelona, Gauss and Neumann, another company based in Barcelona working on SCM and technology, and the support of Mobile World Capital. So on the datathon, we have 12 teams participating, more than 3,000 euros in prizes, plus also tickets for the Mobile World Congress and 4 years from now. So it was somehow cool. Some highlights from the event. So the challenge was to work on a predictive model. I will come to that back to that in a few minutes. Also, and in case you are thinking organizing a datathon, we learned something. It's very important that you pay attention to this, which is, do not share the results of the datathon. For those of you who weren't there, a datathon, participants were given a data set to make a prediction. We forgot to hide the column where they could find the actual results. So it was a kind of painful moment. So we managed to solve that. But just as a learning to share with all of you, if you plan to organize a datathon, please make sure you do not share the results. And we have different teams participating and some winners. A team called Worlds Without Coffee, they were the winners of the Accuracy Prize, and there are 2 teams called Dreamers and Alpha winning the Creative Prize. So instead of me talking about the datathon, we asked Worlds Without Coffee, the winning team, to come here today and in a few minutes share with us their perspective of the datathon. So, Maria, all yours. And an applause for Maria, a spontaneous one.
Thank you, Manuel. So we were the accuracy winning team. I think we were 12 teams. And we're here to present some of the highlights and insights we learned from the datathon. So as Manuel has told, we were told to predict the probability of the NO2 concentration of the following day. We had to see if the threshold will succeed. Sorry, I will start again. We had to predict the NO2 concentration from the next day, and we had to see if it would succeed, it would exceed a threshold or not. As we all know, Barcelona is taking a lot of measures to improve air quality in Barcelona, and that made the problem for us very challenging and real, like in the ethics part, because we were not predicting some sales or anything like that. We were predicting a real problem in Barcelona. All teams were given with the 24-hour histories of. We all had 24 hours to predict the best accuracy model, and we had to make the model that would predict the NO2. We were given NO2 historical data, and we were given Barcelona Supercomputing Center's NO2 predictions. So with these 2 data sets, hourly data sets, we had to make the best model. Achieving this goal, so to say, achieving to predict a good NO2 concentration would give just a hint on how machine learning techniques can improve the actual predictions from Barcelona Supercomputing Center. So what was our model solution? As I've said, all our data was early data, and we had to predict only one value per day. So the first part was to typically clean all the data and prepare daily data. After we had all the data in dailies, we created all the features. So the maximum NO2 concentration from the previous days, from the 2 previous days, the mean concentration, the variation, and so on. Once you have your data set prepared, you have to be very, very concrete on how you're going to do your backtest. Backtest in a contest is one of the main points you have to focus. If you don't have a good validation accuracy, you may be overfitting all your models. So one of the team members started doing the backtest, and afterwards we started training all variety of models. We have to say that as data scientists, we started with typical random forest, gradient boosting, and so on. But at the end, we wanted to have like a threshold accuracy that we had to succeed to improve, and we start trying simpler models. In this case, the logistic regression. For our surprise, at the end, the logistic regression was outperforming all the other machine learning models. So please do not ever forget to try the simplest models, because sometimes they work the best. So some of the features we selected. As I said, of course, we saw the concentration of the previous days of NO2. We had the Barcelona Supercomputing Center prediction, so we knew the next days what was supposedly going to be the pollution in Barcelona. We calculated some futures of increase and decreases rates to see how much the variety of the previous days had been. The typically daily and monthly to see if it's a holiday. Well, there are less cars in Barcelona, so there's less pollution. On Saturdays, through the week, from Monday, Tuesday to Friday, pollution starts increasing, and on weekends, the pollution decreases. So we incorporated all those variables into our model. And of course, where were the locations? I haven't said it before, but we had 7 different locations in Barcelona to predict the NO2 concentration. So if it was Montjuic, it's not the same that the station from Gracia, where there are much more cars. Finally, as we had extra time, one of the team members did a little time series prediction. We had like the Barcelona supercomputer predictions, and we used a model we've been working with, which is Prophet. Some of you may have heard from it from Facebook, which makes the time series predictions. So we incorporated these predictions from Prophets into our model. So what were our learnings and what we would like to share with you? If you work in data science, it will also be useful, but mainly from contents that in 24 hours you have to have an execution that works. First thing is that you have to have an end-to-end execution. You need to split the work as maximum as possible to iterate and improve your model. If you concentrate very much in generating thousands of features, but you don't start training your model, you won't have a solution by the end of the night. As I've said, to accomplish this end-to-end execution, we really work, I think, on task each of the members, and only like in the first hour were the 5 productive, but after the first hour, everyone had something to do, and through all the time, we had a model that was improving. Also, you have this, maybe it's only for contests, but avoid as maximum as possible heavy executions, at least at first. So take simpler models. The purpose is to win in 24 hours, so if you have to make the time worth it. And this one, we learned it in this datathon, never discard simple approaches. As I've said, we started as all of us, and we were talking with other teams. We started with more complex machine learning systems, and at the end, our winning solution was a simple logistic regression. So with all this, Alberto and I are here to answer any questions you might have afterwards, and here's the team we were on Worthless Without Coffee.
Thank you, Maria. So later on, you can ask as many questions to these guys that are going to be here. So, and thank you for the really spontaneous applause. That one was really spontaneous. So, just for the rest of the session, just remember we have two great speakers, Carlos Castillo and Gemma Galdon. They will be talking, each of them, around 15, 20 minutes. And after that, we have our usual Q&A round. So, as usual, someone from Business Analytics, in this case, Tim Van Kasteren, you will see in a few seconds, is going to moderate the session. But then we really encourage you guys to ask as many questions because they are great speakers, and you will see, and they are sharing very interesting insights. So, really the values around the conversation. And after the Q&A, we have, as usual, some time for beer and networking over there with water and beer. So before getting into that, just a couple of big thanks to our sponsors. So Shipstead, the company behind Fotocasa, Vivo, Coaches.net, and InfoJobs, among others. So thanks to them, we are recording this session so you can enjoy later on YouTube and see the best moments. So big thanks to Shipstead. And also big thanks to Movistar Center, they just changed the name, for sharing this venue, and also Estrella Damm for the nice beer we will enjoy later. So with no further detail, let me call to the stage my colleague Tim Van Kasteren from Business Analytics. He is going to handle the rest of the session.
Thank you, Manuel. Hi, I'm Tim Van Kasteren. I'll be your panel host for the night, taking you through the session and moderating the discussion. Our theme, data and ethics. I've worked in machine learning myself for more than 10 years, and I've never had any kind of training on ethics. Google, one of the biggest web companies out there, they have a motto for their software engineers: don't be evil, reminding them to build applications that don't abuse their users in any kind of way. But what does that mean, don't be evil? Do you think every software engineer in Google is going to interpret that sentence in the same way? I don't think so. So I think if you're anything like me, we have a lot to learn tonight about ethics, and we have two fantastic speakers to help us do that. The format for these sessions is we'll do the two presentations, and after that we'll do a round of questions. I'll kick off with a few questions, and then we'll go to the audience and give you guys a chance to ask questions to our speakers. So our first speaker tonight is Carlos Castillo, distinguished research professor at Universitat Pompeu Fabra. Background in information retrieval, research focusing on mining content, links, usage data from the web. He previously has worked at Allocate as a director of research, as a principal scientist at Qatar Foundation, as a researcher at Yahoo, and he did a PhD with Ricardo Baza-Yates back in 2004. Maybe some of you know him, on web crawling. And he's the author of the book Big Crisis Data, a book on social media for emergency management. Please welcome to the stage, Carlos.
Okay, thanks for the introduction. I hope you can hear me. I'm going to speak about a very specific topic related to data and ethics, which is algorithmic discrimination. So my intention is basically to show you that I believe algorithms can discriminate, and I will explain exactly what I mean by that in the most precise way I can. Okay? So let me start very far from my comfort zone. I'm a computer scientist, so I'm going to try to borrow some concepts from philosophy about discrimination. And here I'm borrowing from a book by Kasper Lippe Rasmussen on discrimination, that is about what is to discrimination, right? So discrimination is established here as something relative. So a person is discriminated in relationship to another person. And in this case, there is a very formal definition. So a person X discriminates against someone Y with respect to someone zeta if Y has a certain property that the other person doesn't have. This person is treated worse because of this property, and this person is treated worse exactly because one of them has a property and the other doesn't. So in a short sentence, discrimination is differential treatment that is disadvantageous to some group, right? This is discrimination to someone. This is discrimination in general. Now, group discrimination, so discrimination against a group, is a form of discrimination where you have two people that are treated differently. And the reason because they are treated differently is because one of these persons has a property and the other person doesn't. And this property is specifically belonging to a socially salient group. And what's a socially salient group? Is basically a collective of people that, for which belonging to this group determines their social relationships, particularly their relationships of power. Okay? So, for instance, people with green eyes are not a socially salient group because having green eyes does not determine your social relationship, but women are a socially salient group, men are a socially salient group, certain racial categories, you can think of them as socially salient, age, etc. There are many characteristics that put you in a socially salient group in the sense that it determines your social relationships, particularly relationships of power, and that it makes you possibly the subject of group discrimination or not. Okay? Now, a further definition is that of a statistical discrimination. So what's the statistical discrimination? This has nothing to do with computers yet, but the statistical discrimination is when group discrimination, so when you are treated in a disadvantageous manner because you belong to a socially salient group, this group discrimination happens because of some statistical belief, which means that someone has certain data and has looked at this data, and based on these statistics, on the statistics extracted from this data, has decided to treat you in a worse way than another person. Let me give you an example. So suppose you are interviewing people for a job, and there is a woman candidate who is very qualified for the job, and you decide that you are not going to hire this woman because you have observed in the past that women have a higher probability of taking parental leave. So you decide based on your statistical belief that this is not a good candidate for the job, even if the person is qualified. So that will be a statistical discrimination. It's a form of discrimination, but it will be non-statistical discrimination if instead this person will tell you, I intend to have a son or a daughter and take parental leave, and hence you're not based your actions on some statistical belief, but on an observation. So all of these elements, discrimination, group discrimination, statistical discrimination, lead me to the main element of my presentation to you, which is the fact that in machine learning you can discriminate. So we just need to do a couple of things with the definition. First, we need to interpret that these statistical beliefs from which a statistical discrimination, to which a statistical discrimination refers to, are anything that you can learn from data. And indeed, a machine learning system takes data and extracts from this data statistical beliefs. So in that sense, it can accumulate statistical information that enables this from discriminating you. And the other is that we need to disregard animosity or intentionality, which makes things really, which is a very, in a sense, it's very important, because it's very easy to say that the systems that we are building today, we are building them with good intentions. We are not trying to discriminate anyone or we don't have any prejudice. We love everyone. We are colorblind and so fantastic. But we build systems that can discriminate people even without these intentions. So to understand that an algorithm can discriminate, you need to understand that this has nothing to do with the intentionality of the algorithm. It has everything to do with the statistical beliefs that the algorithm acquires through data. And it has everything to do with the consequences of this algorithm in terms of treating worse a person because this person belongs to a socially salient group. Let me give some examples of this to make it a bit more concrete. I'm going to give you 4 examples. One is the most obvious one, which is disparate impact. Disparate impact is simply that a system gives a worse outcome to some group of people, and it does this in a consistent manner. And perhaps most of the cases that you may have read about algorithmic discrimination or algorithmic bias are related to this disparate impact. So for instance, my system is doing predictive policing, and it somehow is predicting that blacks will commit crimes with more frequency than whites, all other things equal, right? Then another element are rules that are discriminatory. And here, if you think of technical people, if you think of association rules algorithm or association mining algorithm, you will find that some of these rules may be discriminatory. Then I'm going to speak about something more recent, which is disparate mistreatment, which is basically disparate impact over people who belong to a particular class. And then finally about rankings. So disparate impact, which is my first example, is the most obvious way in which you can evaluate the algorithms that you are using today. Presents you a very obvious way of evaluating the algorithms that you are using today. So how does it work? You basically compute you take your algorithm. Your algorithm can produce one or two outcomes for a person. So for instance, you have an algorithm that decides whether they are going to give me a loan or not, or whether they are going to offer me some benefit or not, etc., or something good for me. You have an algorithm that's going to decide whether you're going to give me something good or not. And therefore, when I'm exposed to your algorithm, I experience a certain risk, right? This risk is the probability that I will not observe the good outcome from your algorithm. And basically, what disparate impact is about measuring the risk for two populations. So maybe you have measured everything in your algorithm: accuracy, ROC, etc., and AUC, etc., and you are thinking that your algorithm has very good accuracy, etc. But one further way of evaluating an algorithm is by looking at the risk that different populations are exposed to when using your algorithm. So is it true that this is the same for everyone, or do I have a higher risk? The example in the screen is about an algorithm that grants a scholarship, right? And here, if a certain group of people, so for instance, people with disabilities, have a higher risk when faced with your algorithm, then they can claim that there is a disparate impact. They are treated different. They have a different. The consequences of the algorithm are different from them than from another group. Another example is really very obvious, which is, and this you can do both with machine learned predictions and also with human predictions or even human outcomes. So you can take a database of hiring decisions made by a human. It doesn't need to be a machine, or even credit decisions or whatever. And you can mine this data and try to find association rules that include some protected element as part of the rule. So for instance, if you look at this table and you determine that if you're a woman, then your probability of getting the loan is much lower than if you're a man, then you have a case for finding a direct discrimination in your data, even if your data was not produced by an algorithm, even by a human. And you can also, if you have background information, you can even find indirect discrimination through data. So you can find cases where you find in your data that a certain zip code is being denied a certain benefit or is experiencing a higher risk of obtaining the negative outcome from your system than another neighborhood, but then you have additionally background information that tells you that in this neighborhood people from a certain category lives. Then using these two sources, you can produce an outcome saying there is indirect discrimination in this data. Another example is disparate mistreatment or the lack of, or something that has been called lack of equal opportunity. This was discovered, was advanced simultaneously by two research groups in 2017. And the idea is the following. So here in this plot, on the left of your screen, these are predictions of how dangerous a person is, and in this case, an inmate in jail. These are from Compass. If you have heard about Compass or ProPublica's research on Compass, Compass is a system that predicts the probability that you will commit a new crime in the future. So when you go to jail in certain states in the US, you fill in a questionnaire and get interviewed, and based on your answers, you are assigned a certain number from 1 to 10 10 meaning you're a very dangerous person and you're very likely to commit a new crime, and 1 meaning you're really not dangerous at all and you're very unlikely to commit another crime. The same is done in very few places in the world. The UK has some similar system, and Catalonia has a similar system. It's called Riscandi here. And what this system does is to predict the probability that you will commit another crime. And they are very good. These systems tend to be very good in the sense that if they put you in the category 10, which is the most dangerous, then you are much more likely to commit a crime than not to commit a crime. And if they put you in the category 1, then you're much less likely to commit a crime. But the thing is that while it may be true that for 2 populations, the risk of how dangerous these 2 populations are may be different. In the case of the US, it may be true that for some historical and current discrimination, blacks are more likely to commit a crime than whites, which is not true, but even if it were true, when you translate this to the real outcome, which is in this case the people who did not commit a crime, you expect to see similar score. So in a sense, one thing is evaluating discrimination before the fact, like you're predicting something and you're predicting that you shouldn't give credit to these people because they are not going to pay. But if sometime later you look at the people who did pay and your system was giving for these 2 populations of people who did pay but belong to different groups, different scores, then these people can claim that your system didn't give them an equal opportunity because both were good, but your system gave them different scores. And this is disparate mistreatment. It's a bit complex explanation, but I hope at least for some it was clear. And this doesn't need to be the case. You can also have no disparate mistreatment. You can reduce this. Let me mention a couple more things. So another thing is biased rankings. So suppose I go to a search engine. I'm a recruiter for a company, and I'm looking for a market analyst or for an economist. Okay, I'm looking for an economist. Then I go to this search engine. In this case, this search engine is called Xing, and it's very used in Germany, in Austria. It's like the LinkedIn for Germany and Austria. And I notice the following. So I notice that if I search for economist, among the top 10 results, there is 1 woman and 9 men. But among the top 40 results, the proportion of women is much higher. It's 27%, not 10%. So what this system is doing, even if it's producing overall an outcome that may be representative of the population of economists that are men and women, suppose it's 27% are women, when you look at the top of the results, you only see 1 woman, but you see her in position 1. So how do you really reason about? How can one reason about this sort of ranking? So how can we reason about ranking? Because rankings are everything. If you work in search engine optimization, ranking is literally everything. But in general, rankings in search engines for people and for web pages determines a lot of your opportunities. And in this case, we need ways of reasoning about whether a ranking system is giving a fair opportunity to 2 groups. And in this case, what I'm trying to show with this slide is that it's not clear because it depends on how deep you go in the ranking. And maybe if you're going to examine 40 results, you will see 1 distribution of men and women. But if you look at the top 10, you're going to see another. And one of these is what you will be exposed to. And the other one is just the background data. And maybe it's irrelevant because nobody's going to look at the person who is in position number 40. Now, let me finish with a couple of things. There is let me just give you, I'm going to skip one, but let me tell you something more, which is, it's very important that these systems are transparent. And by transparent, I don't mean that they are open source. By transparent, I mean that you can, as a victim of a wrong decision by one of these systems, you have a way of contesting the decision, of challenging the decision in a way that is effective, right? So I get a prediction from the system, I'm denied a loan, or I'm denied parole, or I'm not allowed a certain benefit, but I need to have a way of effectively challenging the decision and say the system was wrong in my case. Because the system is not perfect. The system will not have 100% accuracy. But as a person who has been not obtain a benefit from this system, I should have a way of effectively saying the system was wrong in my case because of this and this. And this is transparency. Anything else is not transparency. Anything else is just like a pretension of being transparent, but it's not transparency. Transparency means I'm actually being able to challenge an algorithmic decision. And there is this whole idea introduced recently about algorithmic impact assessments, like estudios de impacto algorítmico, that are similar to the environmental impact assessment, which will be the estudios de impacto ambiental. So this is algorithmic impact assessment is a kind of a new development where you really, as a public organization or even as a company, you have a way of a series of steps that you can fulfill in order to provide to in order to avoid exposing the persons who use your algorithm to some damage. So in conclusion, I would say that algorithms, given that algorithms can treat a certain person differently from another in a consistent manner, in which this consistency comes from the fact that a person belongs to a socially salient group, and this treatment is based on statistical beliefs, an algorithm can discriminate. As long as we disregard intention, an algorithm can discriminate. And current research is looking at these trade-offs on fairness and utility. Okay, I will finish with one slide, like just to use the opportunity that I'm here. I would say that I have I'm interested in a PhD student. I'm looking for a PhD student on algorithmic discrimination. Okay, that's it. That's it for my. Thanks.
Thank you very much, Carlos. All right, and then our next speaker is Gemma Galdon. She is the founding partner and director of Eticas Research and Consulting. It's a firm that is advising international organizations to address challenges in privacy. She's on the advisory board of Privacy International and has latest publications that address the relationship between privacy and technology. She is the finalist EU Woman Innovator of the Year and of the Technology Playmaker Awards, and she often advises the European Commission on topics like privacy. Gemma, the floor is yours.
Thank you. Thanks for having me. I think it's pretty obvious that technology is changing everything around us. Like in the last few years, we've seen the way we pay, the way we relate to each other, the way we fall in love change because of technological developments. And we love technology, but we also kind of hate technology sometimes. Our relationship to technology tends to be a mix of trust and reluctance, of love and hate, as I said. And how did we end here? How come something as amazing that can change the way we feel and love and relate to each other and find jobs and find happiness, how come we hate it sometimes? I don't know how we got there as a society, but I can tell you how I got to my reluctance of technology. So let me tell you a bit about my PhD. I started my PhD over 10 years ago, and I finished over 5 years ago. My PhD was on CCTV, on video surveillance on streets. And so I started studying how technology was changing our cities and the way that we interacted with public space. And it was fascinating. And I learned a lot. And I could see as a sociologist and policy analyst what potential technology had to tell us different things about our environment. So it was a thoroughly enjoyable process. And then one day, I was reading Richard Sennett, who you might be familiar with, in one of his great books, The Fall of the Public Man. And at one point he said, in a city full of sensors and cameras and surveillance everywhere, where would Romeo and Juliet fall in love? And I thought that was such a great question. And I thought it was so bad that I had completely lost perspective, because I wasn't thinking along those terms. I was thinking in terms of social dynamics and how the camera was capturing those social dynamics and reproducing them. I was looking at metrics and policies and interviewing users and non-users, but I completely lost perspective. I wasn't asking, so why are we actually investing in this technology? What kind of societies are these technologies creating or promoting? I, as a social scientist, forgot that very basic question. I forgot to ask, are we building the cities that we want to build? Do we want to live in a world where everything is remembered? Do we want to live in a world where if you're the children of the Capuletos and the Montescos, you cannot fall in love because your families have a big conflict among them? Is that what we want? Do we want to live in a world where we can never forget? For the first time in history, forgetting is more expensive than remembering. That's a fundamental change in everything. If you're young today, everything you've done and everything you'll ever do will likely be recorded somewhere. You will leave a digital trace of everything that you do. Do we want to live in a world where the picture of that party, where that criminal record, where that moment that we want to forget chases us and can show up unexpectedly and ruin our lives when we're not expecting it? Is that what we want? These are the things that I had to ask myself when I was doing my PhD. Do we want a world where everything that we do is chased and followed and recorded by a camera, a sensor, the drone that was passing by, our mobile phones? We go to the toilet with a sound sensor, a movement sensor, 2 cameras, and an operating system. Really, that's how we behave these days. Is that desirable? How come at no point have we asked or wondered, do we want this? Is this something that's doing good to the world? Is this how I want to lead my life? And if I don't, what do I do? So these are the things that we try to think about from the perspective of the ethics of technology. I was very lucky that I finished my PhD when these questions were beginning to emerge. And today I work on lots of different fields, not just technologies in public space. So I've had the chance to relate with lots of technological developments in different scenarios and in different contexts. And I want to share with you some of the things that we found in specific projects. Together with my team, we work a lot, for instance, on border control and smart borders. You may have seen how border crossing has changed in the last few years. Oftentimes, you don't even have a border guard checking your passport. You go through a machine, right? You put your passport or your ID, it checks your biometrics, and it decides whether you can go through the border. That's called smart borders. And the European Commission has been promoting them for the last few years. They were installed in the US way before they were installed in Europe. So we've been working with the industry, but also with the European Fundamental Rights Agency on assessing the impact of those new systems that control border crossing. And we found some really interesting things. We found initially, for instance, that smart borders were not part of the legislative debate because they were technical amendments. So the automatization of border process of border crossing was not part of a parliamentary debate because it was seen as just a technical amendment to the current non-automated process. So there was no policy debate around whether we want this or what the implications of that would be. And we've seen that in lots of other fields ever since, how technical decisions don't go through the public or policy debate because they're just seen as this technical thing that techies should deal with, and we shouldn't talk about that because it's not relevant. And it is. If you notice, today, crossing a border is irrelevant because of technology. When you get to the airport and cross the border, it doesn't matter anymore. You got there because you could. You started crossing the border when you bought your ticket or applied for a visa. And you will only stop crossing the border when you go back home, because there's going to be systems chasing you in case that you overstay your visa. So the moment of crossing the border is irrelevant. because of technology. But because this is due to technology, we haven't had a debate about whether we want this. That's not the only thing that we found. So we found that technology changes the physicality of borders, something as important as that. But we also found that technology is changing the way we relate to our bodies. So before, if you wanted to hide your identity, you would burn your passport. When your identity is biometric, what do? You self-mutilate. That's what migrants are doing these days to avoid being sent back to their countries. That's one of the externalities, one of the consequences of this policy initiative we've had in Europe and the United States, is that migrants, when they want to hide their identity, sometimes for legitimate reasons, they need to harm themselves because their body becomes their enemy, because their body reveals that information that they want to hide. So that's a fundamental change. How come we can hide this under a technical amendment? How can we let these things go through without a social and policy debate? But also, what happens with false positives? What if the machine makes a mistake? What if you're not allowed to buy that ticket or cross that border because there's a mismatch in the databases somewhere? What do? Who do you go to? Well, surprise, there's no redress mechanism. When we planned smart borders, we didn't think that smart borders could fail or make a bad decision. Because we just never think that the technology can make a mistake, right? That's human beings. Well, human beings code technology, and so technology can make mistakes. And we need mechanisms of redress. And the previous speaker mentioned that, and that's one of the emerging rights in the ethics of technology in this day and age, that redress mechanisms and the right to redress is one of the new rights that we need to claim in lots of different areas. We found the same, and I think that in the initial example that Manuel posed on Palantir and the predictive analytics used in policing, we keep finding all these issues that he mentioned. We keep finding bias, we keep finding bad questions being posed to the technology, and of course that leads to bad results. We've also worked a lot on smart cities. And it's just amazing how cities are buying more and more technologies and more sensors and more developments and more things to install everywhere that are very visible so that the city looks as this very techie place and very cutting edge. And it can be in the rankings of the most technological city in the world. And we always lack an analysis of what are the problems you need to solve that technology can help you solve. I would urge you, every time you come across a technological solution, to ask yourself, if this is the solution, what was the problem? And you'll find that most of the times, there's no relationship between the solution and the problem. We adopt technologies just because we have them, just because we can, not because we need them. And one of the principles that we try to promote in the ethics of technology is always start with a problem. So you have a problem you want to solve. Technology may or may not help you. Let's see how we can do that. But starting with the problem, it's very uncommon and very unusual in technology. And in smart cities, the compulsion to buy new things is just unbelievable. I also wanted to mention, we work on lots of different fields, and I'll have no time to go over everything. But we did a project almost 2 years ago on citizen science. We were assessing the ethics of some citizen science projects. It was very interesting, because I guess you all know what citizen science is. It's this process by which researchers that need to gather a lot of data, that it would be really expensive to gather. They had to deploy people in lots of places. So you want to monitor how the sea moves or how birds fly. If you had to send researchers everywhere to take pictures of the same sky, the same day, the same time, for you to process that data, that'd be really expensive. So what researchers do is they publish a call and say, if you live here and you don't mind sending me every day, every month, every week, whenever, a picture of what you see out of your window, then I can process that. And if there's a lot of people producing data, I'll have huge data sets that will improve my science. And there's a lot of people that want to help science and so volunteer with this information and take part in what what are called citizen science projects. What we found is that the lack of respect for the privacy of those people was amazing. We managed to expose and access not just the metadata, but also the personal details of the people that were sending their information to these systems. So we found what I call a case of data despotism. Everything for the people, with the data of the people, but without the people. So we never asked them, do you actually want this? We never protect them. It's just data, data, data. Give it to me, because I'm doing something good for the world. And with this assumption that what we're doing is good for the world, we just feel that everything else can be forgotten. And that is not the case. So we're trying to build a citizen back in citizen science and helping researchers take some responsibility for the data processes and the privacy of those that help them. We've also recently started a project on data in elections. And that's also another area where recently we found everything exploding before our eyes, the issue of fake news and algorithmic journalism. Basically what happened is that several years ago, we all celebrated the end of the gatekeeper. With the internet, you didn't need to be a rich person closely associated with power and money to have a newspaper, to produce news, to have a news outlet. And that was seen from all perspectives as a good thing. We killed the gatekeeper. Everyone can produce their own news. We can all be broadcasters of the things that we find are important, which is great, but it's also not so great when you have algorithmic journalism, so machines and algorithms that just reproduce news regardless of what they say. And we've had clickbait, and we've had the reproduction of fake news. So something that we just heralded as this great thing, no gatekeepers anymore. And now I think that deep down inside, some of us hope that there was some gatekeepers, or that we are able as a society to reproduce something as a gatekeeper that we can trust, that can tell us what is true and what is not true. Also issues of algorithmic discrimination, and Carlos explained that really, really well. But just to give you another perspective on algorithmic discrimination, we did a project on smart CCTV. Smart CCTV is CCTV that includes video. And we were testing that includes automatic recognition of patterns. So it's not just, you don't just see a screen and people move and you need a police person or a security guard to assess what is happening, but the machine itself can identify whether someone's moving in an area in a way that is suspicious. So these smart CCTVs, important mainly in airports, banks, and areas that are seen as, that have high security risks. And so we were testing these systems, and that was a couple of years ago, maybe 3 even. And it was really interesting because we realized that we never installed them. That was part of a research project. And we realized that if we were to actually test those smart CCTVs, they probably would not spot criminal behavior. They would probably spot old people, because they move around in different ways than most of us young, white people that are always in a rush. If I go to a bank, I'm just in and out. Like, I don't want to waste time. I went this morning, half an hour. I did not need that in my life. Just go in and out. That's what everyone here would do. So we code that as normal. And anything that is not that is abnormal. Abnormal means criminal in the context that we were working in. So by translating our values into the system, we were making everyone who was not a middle-aged white professional the object of suspicion, because for us, that was not normal. And you know, old people, lucky for them, they have a lot more time than we do. In banks, you have couches, it doesn't rain. So what we found is that people would move around the bank in very different ways to the ways that you and I may choose. And that's not suspicious. That's just different. But we had been unable to understand the diversity of humankind in our system. So just for you to realize how many fairly basic things we are forgetting in the process of conceptualizing technology. So even at the early stage of thinking what it is that we want developed. So basically and I'm going to start wrapping up, one of the things that I found, and I think that the main conclusion to my work up till now, is that the way we do technology is deeply irresponsible in all fields and in all areas. There's no way that a pharmaceutical company would be allowed to sell a drug or a medicine that solved one problem and caused another. Yet with technology, we keep developing and selling things, solutions, what we call solutions, that may solve one thing, but cause lots of other different problems. And I think that the case of algorithmic journalism is a good example here, or the case of smart borders that I just mentioned. And that needs to stop. We need to stop being able as a society, but also as engineers and also social scientists, we need to be able to start asking the right questions. And we're not doing that at the moment. And I blame computer scientists for that, partly. Let me finish. I saw a tweet that really made me think, because I think it encapsulated what I've been thinking about this for a long time. You know, with the atomic bomb, physicists had a chance to realize that what they were doing, that the output of their research could end humanity. And so the ethical debates in physics have been amazing. You meet physicists these days, and it's just amazing how deep the discipline is. There's some areas in physics that only care about ethics. And so they've become much richer because of that. So they had the atomic bombs. Think about chemists. They had dynamite. When dynamite was invented, chemists had to reckon with the consequences of their research and their work. Who was Alfred Nobel? Why do we have the Nobel Prize? Because of the guilt and the awareness of the negative social consequences of the inventor of dynamite. Chemical weapons. Chemists had to realize that their work would end up driving weapons. And so they incorporated ethics in what they do. Computer scientists have not had to face the consequences of their actions yet. And so as a discipline, they're completely oblivious of all these aspects, of the people that are left out, of the consequences of every false positive that is just a number for them in an Excel sheet, but that is actually human rights from our perspective. But it's not only computer scientists. There's also shortcomings in the social sciences, where I come from. I think we've been really, really bad at foreseeing some things. What I mentioned about fake news and the gatekeepers in journalism, I think that the celebratory tone that sociology has had for the internet was completely wrong. We failed to see the risks that came with all this potential. If you go back to Castillo's and the Information Society, it's only about the good things. What about the risks? What about the mitigation strategies for the risks? We never thought about those. And so in a way, we left you, computer scientists, technical people, alone in coming to terms with these issues. Not only that, our methodologies to research all the things that I just mentioned are really bad. Like, if you ask me what I think about traffic in the streets, I have an opinion, okay? I leave my house every day, I see cars. There's cars in my family, so I have an opinion. If you ask me about social services, I have an opinion. I go to the hospital, so I know what I need. If you ask me about technology, I know because it's my job, but most people around me don't know. So we do surveys, and we ask people, do you think it's okay to sell your data for profit? Like, do you think that what Mark Zuckerberg is doing is good? 90% of the people say, of course not. Like, you know, just the idea that someone would buy my fundamental right to privacy, that's completely wrong. And so we come up with all these surveys, very expensive to conduct, by the way, that say that most people really value their privacy and think that it's wrong to offer money in exchange for personal data. Then real life, and we give away the data in exchange for the picture of a cat. So in the survey, we said, this fundamental right I really care about, practice, oh, cute cat. Yes, data, go. So, and we should improve our methodologies, right? Like we need to, when we talk to people, we need to realize that people don't have strong opinions about technology yet. They don't know enough about the black box to tell us what they think. So probably surveys and the methodologies that we're using are not the right ones. And we're not, I find it really hard to come to find papers that discuss this, how to research the information society, how to ask people about preferences when it comes to technology. We've also been really bad at translating what don't be evil means. We've just said, don't be evil, and it was mentioned before, and just left all the engineers out there just come up with a definition of evil, you people. That's just wrong. It was our responsibility to decide how to translate the good things and fundamental rights that we keep mentioning, discrimination, human rights, etc., into code. And I think we failed to walk to the middle of the bridge. I don't think we would have found a lot of computer scientists in the middle of that bridge, but at least we should have made the effort. Luckily, things are changing. I think there's people coming from both sides and willing to have the conversation. But I do think there's also some blame on social scientists for this. We're also becoming really good at blaming algorithms for everything, even from the social sciences. Like, why accept that society is changing in ways that we don't understand when we can just say that the algorithms made Trump president? It's a lot more comfortable to assume that technology did evil things than to understand that maybe as a society we've evolved in ways that we may not find particularly pretty. So the algorithm blaming needs to stop, and I think that's also the responsibility of social scientists. I also think that ethicists have failed to an extent. I fear that unless we change the way we interact with technology, unless we change the way we talk about technology, we're gonna come across what I call ethics fatigue. If all we can do is criticize what other people do and not come up with solutions and with technical translations of the values that we say we want to defend, people will just get tired and say, you know what, we listened for a couple of years, we thought you had a point, but we've moved on. So I think ethicists have the responsibility to start working with engineers and to put specific solutions on the table. And I think that some of them exist. We're organizing the Privacy Enhancing Technology Symposium in Barcelona in July, which is a gathering of engineers working specifically on privacy enhancing technology, so technical solutions for privacy problems. So I think there's some movement there, but we need to get a lot more active in this. So just to finish, I think that we need to get better, be better, and do better. What we're building, it's not just some consumer technology. Social media and the things that are on the news all the time these days, or smart borders, this is not just about your consumer choices. This is about the infrastructures of the future. We are building the socio-technical infrastructures that will underpin everything, technical and not non-technical, that we do in the future. Our societies will be shaped by the decisions, social and technical, that we make today. So I think that we have the responsibility, and for me that's the big word, we have the responsibility to do it better. Computer scientists and engineers, social scientists, ethicists, and all the disciplines need to get together to solve the crucial issues of our time. How do we build socio-technical infrastructures that are responsible and desirable for our generation and the generations to come? Thank you so much.
All right. Thank you very much for that. I kind help but feel a need to defend computer scientists a little bit, saying like, who would have expected that a platform for sharing cat videos would end up influencing presidential elections, right? That's.
You know, when Mark Zuckerberg, I think it was yesterday, he said, society is way more divided than I ever expected. Okay, fair enough. But he's the same guy who said, I want to change the world. You can't say I want to change the world unless you understand the world that you want to change. So one comes with the other. Oh. So if you didn't know that cat pictures could change elections, then just don't get involved, you know.
Yeah,
do something else.
So I want to start off a little bit fundamental. And I struggled a bit to get this question right, so let's see where you take it. But what is the goal of ethics for society? Right. So the goal of ethics, you know, don't do something right, don't do something wrong, do something right. But for society, what is the goal that we're trying to accomplish here? Whoever wants to go first.
I'm not an ethicist. I don't know. I don't know.
In your own words.
No, I don't know. I think it comes with the struggle to do good things, to enjoy good things. Maybe in a more narrow sense, I would say, yeah, it's a mixture of like having a positive impact and avoiding having a negative impact. Right? So the beneficence, non-maleficence, justice. I would say those are very prevalent in this profession. In a more concrete way, right? Not ethics in general, but these things: beneficence, non-maleficence, justice, and I'm forgetting one.
I'm not sure I have like the short answer to that. I think that the main goal is to understand, promote the good things and the positive potentials of technology, but also mitigate the bad things. So it's basically to improve. I think that computer scientists have a lot to bring to the table, but they will not realize their full potential unless they get together with others. And I think that's my greatest fear, is that unless we get together, we will not be at our best. And so the technologies that we will develop will not be the best that we can develop, or would not even not be good enough. So I just think that we need a multidisciplinary conversation. I always say that innovation without values is lazy innovation. Like, the hard part is to take into account society. And that's when you really need to get your mind thinking and understand complex issues. To come up with something that you don't know if it respects the legal framework or whether it will have a negative effect in the long run, that's the easy part. And I don't see that as innovation. So for me, one of the key parts of responsible innovation is being able to actually ask the hard questions and not be lazy.
I will add something that I think is important for computing people. I think it's not, I think one shouldn't, as a computing professional, researcher, one shouldn't consider ethics to be a boundary. Because the boundary in most of data science, let's be concrete, in data science, the boundary is often very far from you, and you have a lot of room to move around, and that gives you a lot of opportunities to make people miserable, to make people's life miserable, without crossing an ethical boundary, just by doing things in a way that annoys people or reflects wrongly on a certain community, or causes some harm to a certain group of people, and you're completely inside the boundary. So it's more like a direction, right? And this direction towards the good things, like try to do good, and away from bad things, try not to do bad things. But I wouldn't see ethics as a way. I think for data scientists, it's not a matter of what are the boundaries. It's more like a matter of what is the direction than the boundaries.
But isn't it interesting that in medicine, no one complains that they have to go through all these processes before they can actually sell something, because they have to prove they will not cause more causalities and more deaths than not having that medicine. So how come people are asking that in computer science? Like, I think we are promoting laziness and irresponsibility when we're not asking them that there's a need to address these issues. Just like in any other field. Like in any other field, if you want to access public funding, you need to ensure certain very basic things. For some reason, we forgot about data. But I think it's high time for us to reintroduce responsibility and ethics into that debate, as we've done elsewhere. So it's not, I don't think we're focusing on computer science because we have a thing against data. It's because everywhere else we do it. And so we have the precautions in every other field that we don't have when it comes to computer science and data.
Right, but I mean, we live in a capitalist society. We have public traded companies that have shareholders, right? If a company says, yeah, we lost 20% of revenue, but we're more ethical than our competition, right? The shareholders are not going to reward that. Right? You say there are no boundaries, but with GDPR, restrictions on how much data we can store, this does introduce boundaries in terms of what we can innovate on. Yeah, if you look, if we go back to Zuckerberg, he says, okay, we're offering a free service, so we need ads to pay for it, right? Elon Musk is coming out a lot nowadays, saying we need to regulate AI before we even see it failing, right? But how do you do that? I mean, you don't even know where it's going to be abused yet. It's very difficult, I think, to do this up front. So what the GDPR is going to bring is a lot of limitations, I think, in what we can explore, and possibly limit innovation in that sense. Any thoughts?
Lots.
Go ahead.
Do you want to go for it, or you want me to start?
Yeah, go first.
Do you think that having cars that can only run at, 350 miles per hour? Is that a limit to innovation?
Yeah.
How so?
Because you're limiting the speed of transportation that we can accomplish.
But a limit to innovation. We limit the speed.
Mm-hmm.
Have we limited the innovation?
Since there is such legislation, there is no value in creating something that goes faster than that speed, right?
And we all accept that cars need to have speed limits and streets need to have zebra crossings and red lights, because otherwise the people that would die or be harmed by this technology would be unacceptable from a social perspective. So basically, we've been limiting technology forever.
But that's from a point of safety, right? Not necessarily ethics.
It's both. It's both. There's also the issue of the limits to the pollution that cars emit. That's also a social concern. So limiting technology is something we've always done, and we limit it for social issues because society comes first. And society guides what things within society can do. We have laws and regulation because capitalism is our economic system, but the political system is a democracy. So I think that we always need to put all those things in relation. And I can tell you a long list of companies that have lost so much money for not taking this into account. Think about InBloom. InBloom was the first edtech company that was portrayed as having to change the world of schools. It was offering cloud services to schools. It got 100 million euros from the Bill and Melinda Gates Foundation. It was funded by the Carnegie Mellon Fund, loads and loads and loads of money poured into this company that had to be the poster company for EdTech. When teachers and parents started asking, how do you treat our data? Where is it going? Are you selling it? And InBloom could not respond. InBloom went bankrupt. All the money was lost. So what I would tell you is that it's more, from a corporate perspective, it's more expensive not to take these issues into account than to ignore them. Just think about Facebook. Shareholder value went down, and the only reason why so many people trusted Facebook is because they lied about what they did with the data. So there's limits to lying even under capitalism. You need to be transparent towards your consumers and also your shareholders. I'm thinking also of the case of the full body scanners. When full body scanners were introduced in airports in 2010, that really started the debate from a policy perspective, but I remember that very clearly. Lots of companies produced pilot full body scanners that were sold to lots of countries. Spain bought 2, I think. They cost €500,000 each full body scanner. in the end, they were not installed. So we were working with the security industry at the time, and they were telling us how much money they had lost, because no one thought about the acceptability of the full body scanners, so they had to be retrieved. So in the end, they came up with a pilot. They sold 2 in best case scenario. They lost all the money. The states lost the money, but also the trust in those states and in those companies also suffered. So I think that it's privacy and ethics are a competitive advantage. And that's going to be more and more the case as society becomes aware that the data is a sensitive issue, at least.
Yeah, I want to complement briefly the answer, saying that to a large extent, we should avoid generating a backlash against data science, even more than what it is. So now it's kind of data analysis is becoming a negative term. And very bad. I find it very bad because we have a degree in data science, right? And now it's becoming it's being associated with negative things, and I don't like that. So I think we should be taking care of our own profession and our own playing ground by ensuring that our actions do not harm others, and not only that they don't see that we are harming them, but we don't actually do harm to them, because that's the best strategy. It's a sustainable strategy to make this profession valuable and to continue creating value and making money out of it. Otherwise, somebody's going to invade the playground. Yep. This is not good for us.
I remember a conversation with one of our clients, a large telecommunication company, that said that they wanted to work with us because they realized that there were all these bad players giving data a bad name, and they felt that if there's all these players stealing data and doing bad uses of data, that would in the end affect the trust of their customers towards them. And so they wanted to make sure they were seen as a trusted entity, and they wanted to see what steps they could take to do that. So I think there's more and more industry players realizing that they cannot afford to ignore these any longer.
Right. Then a technique that has become very popular in recent years is deep learning, which, if you look at it from a machine learning perspective, it's more and more a black box than many of the other algorithms that have been out there. It manages to basically incorporate a part of the feature engineering part into that black box, so that we can really just feed it a very large amount of data and ask it to do something, and it will figure it out some way or another. We have no visibility on how to do that. Does that make certain matters that you discussed in your talk, Carlos, more difficult to address?
It's already, so I think a good analogy will be, think of like a human judge versus an artificial intelligence judge, right? So, and both are presented with a certain case. So they see a person who is a defendant, they see someone who is accusing them of something, they look at the evidence, and then they produce a verdict, okay, guilty or not guilty. The human judge is really a black box. His or her brain that's a black box that is much more black than any of the black boxes that we create in machine learning. It has orders of magnitude more connections and so on. But this human judge has to explain cannot explain perhaps the entire reasoning, but has to explain what is the evidence that he or she considered, how was this evidence considered, and what are all the sources of this verdict, right? Maybe we wouldn't know all the details, but we have a way of making this process a bit more transparent than what it is. In the case of a machine learning algorithm, I think the same applies. We are well past the point where you can actually inspect the algorithm and see something meaningful on it. Even in simpler models like a logistic regression, you see the coefficients, but maybe you have 12,000 features or whatever, and you don't see anything, right? Even if the thing is really in front of your face, you cannot see anything. So it's more about algorithms that can produce an explanation, just as a human judge will do, and that this explanation is useful to people who are affected by this and allow them to do a redress procedure or something like that.
Mm-hmm. Mm-hmm. Yeah, the fact that we've been so bad at addressing the easy questions makes me very skeptical about our ability to address the hard questions. And I think that automated learning and machine learning, it gets complicated and complex. But we do have the methodologies. If you can we need to see how to do algorithmic transparency because there's trade secret issues and intellectual property issues and stuff. But we can check how an algorithm has learned by doing reverse engineering, for instance, or by testing the results of that system. So I think we have ways. Like I haven't seen any technological problem so far that has ethical implications that cannot be addressed one way or another. For me, the problem is more the unwillingness to activate the mechanisms that we have than those mechanisms not existing. We have the tools. Oftentimes, companies or institutions don't want us to use them for some reason, and I think that's a struggle that we're in at the moment. We need better ways of auditing and monitoring what machines are deciding for us.
Tim, we are a bit ahead of time, so let's open the Q&A. So anyone with questions for the speakers? Yep. Say your name up front.
Hi, my name's Alistair Porter. Thanks to both of you for the talks. Both of you talked about this idea of transparency, and so being able to ask what was the reason that an algorithm made that particular choice. And as I understand, that's one of the new measures that are becoming required, especially with the GDPR legislation. Do you have any suggestions or thoughts on whether this is actually going to help in the future, the legislation saying that you must have the ability to do this? Is it going to help to solve some of these problems that we see are happening?
Thanks. So the GDPR establishes this kind of right to explanation for cases where an algorithmic decision-making affects you in a way that is significant, right? It says something like significant or a similar word, right? So it's not any algorithmic decision-making. I think this transparency is fundamental for trust and for exercising certain rights, but it's not everything. Especially, for instance, you can. Transparency is less useful if you receive it after the fact, after the system has been established and has been running for 5 years, and then somebody decides to open it up and discovers that the 20,000 people have been giving a negative answer when they should have obtained a positive one. And where this algorithmic impact assessment process comes is perhaps trying to preempt those problems and creating like some organized way of discussing these issues before putting the algorithm in practice, just as clinical trials do with medicine. I think in the case of public bodies instituting automated decision-making systems, they should be the first to start establishing some algorithmic impact assessment procedures.
I think transparency is clearly a good thing, and we need to promote it, but I don't think it's the solution to everything. With machine learning, transparency doesn't really help because if your credit card gets blocked by your bank because you've done something suspicious, and you go to your bank will be completely unable, and Kathy O'Neill describes this. Your bank will be unable to tell you why your card was blocked because they know what they coded in the algorithm, they don't know what it learned, and so the specific reason why your card was blocked, no one knows. So transparency in those spheres doesn't mean anything. So I'd rather talk about accountability. I think it's more useful. Also, I mentioned issues of intellectual property and stuff. Some companies may not want to reveal their algorithms, and I think that could be okay, acceptable in some cases. But I do think that we need redress mechanisms and accountability. So you should have a right, if you feel that technology has impacted you in any negative way, to find out what happened. And there's things that show why this is the case. In the US, it was only this year that one person that was sentenced using forensics managed to get access to how the forensics was done. So the DNA analysis, he was deemed guilty because of a DNA analysis. And the lawyer wanted to see how the DNA analysis was conducted. And it was only this year, we've been using DNA for a long time, it was only this year that he got a right to audit the system that deemed that DNA was his. So even with ancient technologies as DNA, we're really lagging behind in terms of protecting the potential false positives. So I think the solution is a mix of transparency, accountability, redress, etc.
One, two more questions. Anyone?
Hello, I'm David. Thanks for the talk. And I was wondering, you said that surveys were not a way to get information from people. And so can you give some introduction of which should be the way?
Yeah, so we don't do surveys anymore. We do focus groups, and we try to create scenarios. And we create close to real life experiences where we can get people in the mindset that they would have in a real life scenario. And that's the closest we can get to actual behavior in real life. But what we found is that asking people, one of the things that we found, for instance, was the gender bias in surveys. Like, so when you're asked something that you don't have a really strong opinion about, you tend to respond what you think people want to hear. And men assume that they need to project that they're tech savvy. Women don't feel that pressure. So we felt that in surveys, men would always be like, yeah, technology, great. And women would be a bit more reluctant. But again, that had no relationship to real life experiences. So things like this need to be avoided. And so we need to create scenarios or do focus group where people can start talking to one another and they talk about their life experiences, and then people can get themselves in a different mindset. So these are the things that at Eticas in our team have shown to be useful in terms of understanding how society may react to new technologies. But definitely not surveys. Forget surveys. Online surveys, yes, no, that's no. Waste of time and money.
We had a few questions over here.
Hi, my name is Thomas. I work as a consultant for as a data scientist for a consulting company. I was wondering about this concept of statistical discrimination you were talking about. And I was wondering, at least in my experience, algorithms only do as well as the data that goes into it. So really, I was wondering, are the algorithms to blame, or is it more about the data? And what can we really do in such cases if we see discrimination in the reprehensible form, other than just detect it? I mean, it's in the data. It's not the algorithm, I would say.
So it's true that it's in the case of in most cases it's true that the data is to blame. So there are some corner cases where the algorithm is to blame. So I will start with that. For instance, a matching algorithm in the traditional stable marriage problem, for instance. You have two populations and they have preferences, and you have to match one of these with one of these in a way that there is no envy, right? So everybody is with the person that he or she likes the most, and you cannot do a swap and make everybody happy. In that algorithm, depending on which side do you start with, you will have a different value for both sides, right? To bring it to more common terms, if you have a society where men propose to marriage to women, men obtain a better deal than women, right? Even if both can argue which person is. So in the stable marriage problem, depending on which side you start with, you have a better fitness or not. So that's a particular case where the algorithm is to blame and not the data. But in most cases, the data are to blame. So it's because you are feeding data that incorporates some historical patterns of discrimination that the algorithm learns to discriminate against certain people. And there are three classes of methods. You can pre-process the data. So you can look in your training data what are the more severe cases of discrimination and remove them so that when you train the algorithm, you don't have them. You can post-process the output, which will be, once you observe the output, you evaluate the risk for two populations, and you decide that you're going to swap some labels or change the outcomes in such a way that the risks are equalized or the disparate mistreatment is avoided. And the third case, there are also in-processing methods where you are trying to jointly optimize for an algorithm that can produce good predictions and at the same time include some penalty for instance, causing a different an outcome that is too different for two groups, like pre-processing post-processing, in-processing methods. Most of the cases, the data. In some cases, maybe it's the algorithm.
Of course, you would run the risk of introducing your own bias, I would say.
Yeah. Plus the designer bias. It's everything, right? So you are training on data. Right? I say, well, I'm training on data, but who selected the data, right? And who chooses how to clean this data, how to filter, where to acquire it from, which features to consider, everything. In the end, everything falls in your own responsibilities. Yes, sure.
And I would add other things to that. We have a new project called Bad Data, which precisely tries to look at the problems with the data that goes into algorithm, so to distribute the blame, so to speak, but also to focus on problems with data. Because in our real life projects, we found a lot of corrupted data, expired data, a huge issue, data that may have been good at some point, but no one updated, or badly coded data. For instance, we were finding in our border work a lot of people being turned down at the border because their original names were in a different alphabet, like Arabic or Thai. And at the time of processing the visa, someone typed it wrongly. And so they would get the visa in the country of origin, but at the border, the police would see a mismatch, and they would send them back. That's a bad data problem, and it's not even about bias. I think that we always assume that data is correct, and it's not. And there's human lives that can be the victims of this badly coded or transcribed data. But also the issue of discrimination. Discrimination can also be good. I was recently involved in the debate at the New York City Human Rights Commission on how to regulate the algorithms being used to allocate public housing. Because the city, New York has a lot of public housing, not like here. And so it's private companies that decide who gets access to that housing. It's not the city itself. And so the city wanted to make sure that the companies that it works with use ethical algorithms when making that decision. And so they are allowed to discriminate by need and income, because that's what they should do. You don't want Trump accessing public housing, but you don't want to discriminate on the basis of race or other things that are not acceptable. And it was interesting because the city just came up with this like 10-point program of don't be evil. And the companies were like, we don't know what you're talking about. Like, yeah, we should discriminate, actually. And we were asked to contribute to that process of how do we translate these good intentions of the city into something that companies can actually work with and that improve the systems and not just leave them being like, I don't know what you're talking about. So this decision, what is good discrimination, acceptable discrimination, and non-acceptable discrimination, that depends on the context. And that's why you need people who understand the context to contribute to that debate.
So I think some people miss the cold beer. So last question, very quick question and very quick answer also. Okay?
Yes.
Yeah. Okay, hello, sorry. I have a question for you. Yep. Actually, I was, well, in my head, I had the last sentence of you, your conclusion that you said that we are using the technology in an irresponsible way. But before you said that, first of all, is the definition of technology that you said that the technologies comes up when we have a problem, and then the technology take that problem and gives us a solution. And you said, therefore, you said that the problem of nowadays technologies is that sometimes we are using technologies that we don't need. I'm correct? Yeah. So the problem is that I was asking to myself, do we really know what we need? Because the point is that, for example, it might be a strange question, but for example, here I have a microphone. This is behind this. There's technology that helps me to speak louder to you, but I don't really need the microphone to ask this question. For example, I could scream, but the point is that for my commodity, yeah.
Can we get to the question, please?
Yes. No, the point is, do we really know what we need? And yes, because I think this question would ask the problem of the technology, the irresponsibility of the using of the technologies.
we know the problems we have. And I suggest we start from there. So there's things that concern us that we think can be improved. And then we look for solutions. And those solutions can be technological or non-technological or a combination of the two. So for me, the crucial thing is not what we need, but what problems do we have? And then that's where I would start the conversation. In terms of understanding needs, you have something called market analysis that can help and may have helped Google a lot before launching Google Glass and Apple a lot before launching Apple Watch. Now we know that we don't need Google Glasses or Apple Watches, but realizing that we didn't need that came at a great cost to those two companies. So I'd encourage them to stop thinking that anything technological is needed, because society has sometimes said, actually, we don't need this thing.
Excellent. So we're a little bit stressed because we'll get kicked out at 9 o'clock. But that should be enough time for one round of beer. So thank you very much for joining. Let's give a hand to our speakers.
Thank you.